Hi everyone, I wanted to go over an additional example for you in section 6.1 that deals with rational expressions and rational functions. So the particular example that I want to look at with you is going to be the following. We will have x squared minus 13xy plus 12y squared, and that is all going to be over 144y squared minus x squared. Okay, so whenever we are working with an expression like this, and again, this is an expression and not a function, because notice that I have two variables that are kind of sprinkled throughout the whole thing, so it breaks down that definition. And if you're not sure what the definition of a rational function is, please go back to your notes or refer to your textbook. But this is just a rational expression. We have two polynomials that are basically formed together as a ratio. Okay, so when we take a look at a problem like this, we want to see if we can actually factor it down. So break it down into prime polynomials, assuming that it is not already written as such. So I'm going to focus my attention on the numerator, so what I'm highlighting in red. And I'm going to see if I can factor this down. Okay, so past experience tells me that I might be able to take this trinomial and factor it down into a product or a multiplication of two binomials. So I'm going to go ahead and, if you need to, for now, feel free to set up a box for your box method. Again, as you do more and more of these problems, you will probably find that you can kind of back off of using the box method, almost like training wheels in a sense. You can get rid of the training wheels and just start doing these in your head, or just start factoring them more quickly. So we would put our x squared in the top left, and then the 12y squared in the bottom right. And again, the x squared, we can break it into an x and an x. And then we do have to think about how to break apart the 12y squared. We want it to break up so that we, when we multiply these two terms that we will have here and here, they will multiply to give me a positive 2y squared, but then they will add together to give me a negative 13xy. So let's go ahead and erase this out so that we're not cluttering up the place. So what I would suggest doing would be to maybe do, well, we know that since our product is positive but our middle term is negative, that we will have negative values here. And let's try 12y and 1y or just y. So if we were to go ahead and take care of this multiplication, x times negative 12y would give me negative 12xy, and then x times negative y gives me negative xy. So if we were to add those two up together, we would get the negative 13xy. So here we go. One of our factors is x minus 12y, and our other factor is x minus y. Okay. So now let's move to the denominator, which I'm highlighting in blue. Okay. So again, if we were to maybe try and break this down into, whoop, put that back up there. If we try to break this down into a product of two binomials, this looks like a difference of squares. Notice that 144 is 12 times 12, y squared is y times y, and x squared is x times x. So we can quickly demonstrate that in the box method. So 14y squared would be 12y times 12y. Negative x squared would be a plus x and a minus x. Okay. Again, we can check this, and here we would get a positive 12xy. Here we get a negative 12xy when we do the multiplication. When we add up those two middle terms, they will cancel each other out because they are additive inverses, or in other words, opposites of one another. So here we would have a 12y plus x, and then a 12y minus x. So here's where you actually need to be careful. I'm going to rewrite the problem below in purple. I'm going to write it so that my lead term in each of my binomials is the x1. Okay, so here we have x plus 12y, and then we have a negative x plus 12y. What I want you to note is what I'm going to circle in orange. These two values look very similar. Okay, they look almost identical, except the signs in front of each term are opposites of each other. So what I'm going to go ahead and do is I'm actually going to factor out a negative from the bottom right binomial. Okay, so this guy right here on the bottom. So what this means is I will have my x minus 12y times x minus y, so I'm just leaving the numerator alone just as I see it on top. I will leave the x plus 12y factor alone, and I'm going to basically take out the negative term. So this is going to be times the negative 1 that I pull out, and this leaves me with a positive x minus 12y now. If you don't believe me, redistribute that negative back in, and you will get back to this negative x plus 12y factor above. Okay? But now look to see what this allows me to do. Notice that now this factor and this factor are identical, which allows me to cancel them out. So what I am left with now is I do have that negative 1. So I'm actually just going to write that negative out in front of my work. And then I have the x plus 12y that I have left over in the denominator. And then I have the x minus y that I have left up on top. So here is my final answer. Okay? I hope this was helpful. If you do have any questions, please let me know.